Perfect. On page 14, while I'm taking attendance, if y'all could take a look at, we're going to be picking up what we did yesterday, trying to finish factoring this. So see what you've got there, get your head kind of like back in it again for me, and see if you can finish factoring. If not, that's what we're going to talk about. But try to see if you can finish off the factoring before we jump into this together. Thank you. Yes, sir. Huh? Oh, I owe you one? Okay. For now, can you just get started looking at this, and I will be there in just one moment. Gio. Samuel. Pedro. Leisha. Johan. Pedro. Kaylin. Carlos. Catherine. Kaylin. Levy. Chi. Jason. Jeremiah. Cindy. Jennifer. Angela. Rhiannon. Michelle. Osi. Now Jason, quickly get your notes out. Omar. Here. Christian. Oh, he's here. Diana. Samantha. Fatima. Natalie. Emilio. Javier. Edgar. Samantha. I know, I got you. You're always slightly late. Well, on the here. On the here. It's always like, I'm like, is Edgar here? And they're like, okay. And then you're like, oh, yeah. Just come slow. Your here is always slightly late. That's a fair statement. Your here is always slightly late. Okay. Here we go. Jason, quickly, your turn. No, no, no. What? All right. Eyes up here. Before you go on to any of the others, waiting for those voices. Thank you. Before you run off to number 2 or 3 with any of the others, I know yesterday we talked about all these things, and it's very tempting to go start writing them for the others, but hold on for me, because what we didn't finish talking about was how to actually find the zeros, and I want to make sure we feel good about that so that we can actually sketch our graph before we move on, okay? As a quick recap, degree and leading coefficient came from here. Possible real zeros, can anyone remind me where I got that number from? What are the real zeros always equal to, OC? The same as the degree or the highest exponent. Okay, I owe you 2 now. And then turning points, how did I get this 2, Javier?
No.
Not quite, so that's close. Wait. Like it's tempting to be like, maybe it's that one, there's a 2. You remember?
When you graph it,
It's going to be physically when you graph it where it turns, but let's talk about where that comes from. All good things. You're saying good things. Look at all the hands. You get space. Oh. Back to me. Cindy. N minus 1. So it's literally whatever this is. Still waiting, no, we're never going to get through it. It's literally going to be whatever this was, the degree, minus 1. So on my poster over here, take a look. N distinct real roots, N minus 1 turning points. Good recap of that. So that's 2. So those things are like, I'd say easy if you know the rule. But like if we don't study or recap that, I was talking about this with Rhiannon, like 2 weeks later on your unit test, if we don't remember that rule, then that becomes like a hard question if I ask you the turning points, right? So keep up to date, like reviewing and practicing problems with this. Okay, and then end behavior, because it's an odd positive, it looks like this. Positive over here, negative on the left, okay? All right, time for the zeros. Can someone remind me, yesterday we got started with this. What did I do first to start solving this when I set it equal to 0? Did we get started?
Yes.
Okay, raise your hand if you can tell me what we did first. Samantha.
You factored out the x.
We factored out our common factor of x because once I did that, I had a quadratic. And what we did not get to do is I could go over here and I could do a box for this part to come up with my factors factoring that piece. So x squared positive 6 minus 5x. I'm going to bring my stamps in while I'm doing that. think of which factors we've got there. I got a bunch of people with it. I'm gonna wait for a few more people that feel like they have it. Do they owe you one? Is that what you're saying? Oh, like calling you. That's what you're like. Okay. All right, Catherine, what did you get for that one?
X negative 2 and X negative
A little louder, and everyone else, no voices?
2. X negative 2 and X negative 3.
Okay, negative 3 and negative 2. And so we get x minus 2, x minus 3. Okay? So I'm going to rewrite them here. This is where I want us, like, if we were practicing well from when we did the box method, we would always then write down our factors. I know a lot of us jump to just writing like 3 and 2 now, right? Okay? But be careful because remember we have this other x that I don't want you to forget. So I'm going to make sure I always rewrite my factored form like this so that I can make sure that I find all of the x values that would make this whole thing equal to 0. So I agree. One of them is going to be, what's going to make this 0? 3. I'm going to come up here because I'm going to this. And 2. But I could also have x equals 0 because if x was 0, this would be 0 times negative 2 times negative 3, and that would cancel everything and be 0 as well. Okay? So there's actually 3 of them, which we knew it was possible we'd have 3 of them, and we just found that there actually are 3 zeros here. Okay? So on our graph, we now have a lot more information. We know that we're going to be coming from the bottom on this side. Can't draw. And we're going to be ending on the top on this side, right? Because it's an odd positive. Odd positive looks like this. That's our end behavior. We know it's crossing at 0, 2, and 3. Right? Okay? And so that helps us, depending on the problem, this could be easier than other ones, but we're going to pass through all of those points, and so we can come up with a pretty good sketch of our graph. And we're going to see some funky things happen today, can't talk, happen today, to where we'll have to be careful with a few of these zeros and some special things that happen. But, for example, for that one, we just cross through all of those roots and head on up, because we know our graph should end up there. Okay? So we have zeros, we answered all these questions, now we have our graph. Cool? Okay, so that's where we left off yesterday. I'm going to come back to some of these other problems underneath in a moment, or some of them I'm going to save to the end if we have extra time, because the practice for today kind of like repeats some of it. But I'm going to jump to what would have been the do first for today if we would have like flown through yesterday, or if yesterday would have been a regular lesson rather than a Wednesday. So take a look on page 16 for me, down in the middle at right here where it gives you this function. I want to see, based off of kind of like finishing off that problem, how we would do with this. So with your neighbors, I want you to take this function and I want you to determine only the following things. It asks for the maximum possible number of roots. We should know how to do that from yesterday, so make sure you got it. The maximum possible turning points, and then I want you to practice what we just went over, which is factoring to find the roots. Okay? Try it with your neighbors. Let's see how we do, and we'll check it in a moment. Try it out.
Pedro.
Yeah, right. Cool. So maximum possible roots. Real roots means it should always be like in this one. Oh, wait, this one. In this one, we said the maximum number of roots is the same as the degree, and the turning points is always more or less, right? So what's the max possible roots? That's what we just in this last one, like recapped, but we wrote it down yesterday, so kind of refresh your memory. If the degree is 3, we said the maximum possible roots was 3, and the maximum possible turning points was, like you said, 1, we decided it was 1 less than that number, okay? So now for this one, what would be our degree of this polynomial? 4. So the maximum possible roots is, that's turning points. The maximum roots is 4, the same as n, and turning points is n minus 1 is 3. Okay? And then now try factoring to see if you can find the roots.
You get the exact same thing.
Okay, good. We got this. 4 roots, 3 turning points. You can actually pull out, see how they still all have an x? You can actually pull out 2 of them. Pull out x.
You want to deal with it?
So the possible.
So now we're going to try factoring. So kind of like here.
I'll do that to you.
Pull down
It sits right there. It sits right there. I'll do
We're
that.
going to do that. So sometimes you can pull out
It sits right there and I'll do that. I'll do
But did y'all factor out an x squared? Cool. It might help you. One thing to be careful of is this was a negative x squared, so it might be helpful to either factor out the negative and change the signs of all of them, or this you need to make sure is negative in your box just to blow up right here. So either way, like if you need to make sure you have a negative out front, but then that would change. No, I think you might be good.
Wait, what?
Did you actually pull out a negative? What is this? I see is a +3. So that would be a minus. Where?
Positive x squared plus 3
This is good. This is good if you leave the negative inside, right? But you've got a negative x squared, so in your box, that first you gotta make sure you leave it negative. Or another option is to pull out that negative as well, so you don't have to deal with it. But you just have to change the signs of both of those. If you make the front one negative, then this would be positive, positive, negative there. But that'll make your first one positive, positive. Hold up. I'm just checking, because you've got the negative inside, which is fine, but let me just check and make sure. Negative x squared. Okay, right here you got the -2 and negative would give you positive 2. And a positive 1 would give you 3. So you gotta play with those negatives. Or pull the negative out at the beginning. But where's this 3 keep coming from?
I don't think Dennis remembers who wants to think.
That's why I went to her. Okay, cool. That looks better. Cool. I'm okay with that. Okay, where? How are we doing? Factor it? We'll factor that part. So now we actually write our zeros. So what So what would make these zeros? Either -1, so that's right, or -0. Based off of the 1, 2, so those are your 3 zeros. Check with each other. We're going to check up here in a second, but. Did we factor? Not yet? Okay, good. I would, though, you pull out actually, take out 2 of them, right? So then this will become 1, and I would actually pull out a negative, so this first one is negative. Pull a negative out. It doesn't matter if you do this, but I just pull out a negative. I would, and then you don't have a negative x squared.
What about this?
Negative 1 is positive 2 and negative 1.
It's flat.
Take the negative.
That would be negative. But that x Check with that. Alright, y'all. I'm going to cut you off wherever you are, and we're going to finish together to kind of keep us on pace with timing. Okay? So, first up, I'm going to go with Cindy, over to you for our maximum roots. Everyone else, voices off. 4 4 because our degree is 4. Okay, next up, turning points. Jennifer, max turning points is 3. And then now we factor. Depending on how you factored this, like some of y'all might have pulled out a minus x squared. Some people might have pulled out just an x squared and had a minus like in their box. But if you work through all this, I'm not going to show all the steps. Let's see if, Samuel, did you get to 3 roots at the end? Still haven't gotten there. Okay, let's see. No, that's not this.
Yeah.
Pedro B. Sorry, do you have it? Okay, then we'll go. Pedro, you can do it.
I don't even have it, miss. That's not.
Does anyone have it? I have it. Carlos, over to you. Sorry, y'all. Okay, everyone else. Carlos.
Carlos doesn't have it.
What? Go.
Carlos is smart.
X equals 1.
I just can't hear him because y'all are talking.
X equals 1. X equals negative 2. And X equals 0.
Let me see. Let me see. Alright, so check your factors. If you factored it the way I did, you would have gotten negative x squared x plus 2x minus 1. So if your signs got off on that or something, check. But that gives you 0, negative 2, and 1. Okay? Kaylin?
If you would have used like this x squared,
Yes, if you get x squared, y'all. If you get x squared, this is what you're saying, Kaylin? Like this? Okay. When you do your box, you should get the same thing. You just have to be careful because of this minus in here. I think since we don't do this in the box as much, you got to be kind of careful with how your box is. But if you do this box correctly, you will end up with these same factors. Okay? Cool. All right. So that we could then take, and again, we could use to sketch the graph. Show me really quickly with your arms what this graph would look like at the ends of our graph, end behavior. I see Gio's got it. Like this. Yeah. Negative, even. We're going to be like this. And then it'll cross at these 3 places. Okay? So that's what we're going to continue to practice today. Quick announcements. And then I'll bring those people their stamps. Remember your problem set is due on Monday. Tomorrow we have a heavy calculator lesson, as in like there will even be steps on the calculator for that type of problem that I will give you on a piece of paper to have as like notes. So if you don't have your calculator, you essentially really cannot like learn properly what we're going to be doing tomorrow. So I need you to have one here so you can participate. We should always have it, but just as like a plug, tomorrow is super important. And your first quiz, just as a heads up, we're still a ways away, but it's next Wednesday just because a couple people have been asking. You can check out your calendar and I'll keep giving you reminders on that, okay?
Thank you, Miss.
All right. So we're going to really quick come back. Not right now, but like later. I'm just telling you, we're not going to leave these problems completely behind. But you might have wondered, like I said, we were practicing today, and we are going to come back to page 15. Has 3 really great problems, 2 that are already factored for you. So we're going to talk today about what to do if they're factored for you, and 1 kind of like we just did, where you can factor it and find all of these things. So the problems we do today are going to be very similar to this. But I'm going to add on 1 more piece that we're going to be able to do when we're sketching. And then if you finish any of the problems that we're going to practice today, page 15 is a great spot to come back and also practice some other problems dealing with the same stuff. Okay? In addition, on page 16, right above our do first, you might have seen this problem. And I've had a lot of like coming out of unit 1, I think some like good suggestions from people of like, I'd like to see more problems like we see on unit tests because I feel really surprised sometimes when I see like a hard problem. So I want to just kind of like ground us, and I think this is the type of problem where people might tend to like freak out and like give up really quickly, but I want to show you how it's actually not that bad, and based off of what we've learned, you could actually knock out in like 20 seconds if you just like clear mind. Okay, so join me really quick at the top of page 16. Let's look at this one together. It says, the number, I'm even going to make this actually non-calculator. I can do it no calculator. I know. The number of acres in the United States used for organic apple production, and by now you're like, oh my gosh, apples, I'm feeling overwhelmed. I'm just going to circle something and move on. Like that, I think that's literally what happens in people's minds sometimes. But stick with it, okay? Can be modeled by AX equals, and then you see this crazy equation, you're like, yeah, nope, I'm out. But stick with it, because crazy polynomial, not crazy problem. Let's see what they actually ask us to do. It says, describe the end behavior. Ding, ding, ding. End behavior means those two limits, which means I am just looking, same as always, for one of these four. Am I even positive, even negative, odd positive, odd negative? Really quick, turn and tell your neighbor, look at polynomial, which one is it, and be ready to share it. It should only take like 20 seconds. Which one is it? How do you know? Tell your neighbor. All right, bringing it back, we've got Cindy. Man, Cindy is the optimistic lady today. Cindy, I got a lot of stamps I owe you.
Where's my name?
Where's your, I don't know, let's flip through them.
Is my name in there?
You just look at the link.
Cindy! They're checking, don't worry.
Hey, you owe me.
What did you think for this one? What type is it? Even positive. Looks like this. Therefore, you quickly knock this out and move on. What are we going to write? Infinity. Infinity, because both of them are up.
Did you just say even?
Even because of the 4. Positive because of the leading coefficient. So the even odd always comes from our exponent. The positive negative always comes from the coefficient. Okay? Okay, I'll find it. Oh yeah, found you. Okay. And if you graph it, you will see that on both sides. Okay? It's going up, up on both sides. Alright. One more to make you guys feel better about the quiz. I'm going to give you another one to turn and talk with your neighbors. Here's a polynomial. This is multiple choice. It's not in there. I just added it. I found it on like an old common assessment. Turn and talk with your neighbors. Which one of these is the correct end behavior? I'm going to take me back now. All right, a few seconds. I'm going to pick someone. We're going to try to get something different this time. Okay, here we go. Samantha P. Oh, sorry. Over to you. Which one?
You said P.
F, because it's a what?
It's even negative.
Even, negative, so it looks like this on the ends, and so F is negative, negative, okay? Cool? Alrighty. Very good. Back to today's lesson. Let's add on one more thing, and then we're going to, I'll put it right here. And then we are going to practice. Okay. For this one, we've got a graph, we've got a polynomial. I'm going to just ask a question, what do you notice? So I actually have already, you notice, like, factored this one and given you your roots, which you see here, 2, 0, and 1. What do you notice about 0 on our graph right here? Think about it, make some observations. What do you notice about 0 on our graph? Rhiannon?
I noticed that the line doesn't completely cross 0, it just kind of bounces on it.
Good. It touches at 0, right? So 0 is a root. I know you one from before. Yeah. Excuse me. Sorry. Okay, so it touches 0, so 0 is still a root, but it actually just bounces or touches 0. It's tangent. It doesn't actually cross from positive to negative and like loop down here, right? The turning point is still up here in the positives. It doesn't cross to below. Okay, so we today are going to learn when on our graph, so that when we're sketching it, we know when we're going to cross the x-axis and when we do this and we just bounce and just touch it, okay? Let's look at our equation to see if there's something special about where 0 came from. Do you agree 0 came from that piece of our polynomial, right?
Yes.
Does anyone now notice, part 2, notice, what is different about that factor of our factored form of the polynomial? Anyone see anything special on that factor? Omar, want to give it a shot?
I noticed two things.
Okay.
I noticed it's negative and it has a square.
Okay, so which one is important? What we're going to be looking for today is if it has a square. That actually means that I could like break this up if I really wanted into 2 x's, right?
Yeah.
So actually, either of these x's could have been 0. Like technically, we have x equals 0, x equals 0, x equals -2, and x equals 1. That's what we call a double root. Okay, and at double roots, we're going to get this bounce instead of our crossing. Okay? At double roots, we're going to get the bouncing and our crossing. So let's sum that up right here in this box on the top of the next page, and I'll keep this example here so that we can kind of connect it back to our example. If we have x minus c to the m as a factor of a polynomial, we call that power up there the multiplicity of our factor. We're at the top, I think, of the next page. The multiplicity of our factor, where m is a natural number. Okay? So if the multiplicity is odd, in our example, technically, what little power is on here if nothing's there? 1. Technically, that's an odd number, right? So if your multiplicity is odd, it is going to cross the x-axis at that point. So at -2, it crossed because this is odd. Okay? At 1, it crossed because this is odd. Okay? If the multiplicity is even multiplicity, then they say the graph is tangent to the x-axis, which means at 0 right here, since this was a 2, it was even, it like more, I don't know, there's different ways to think about it. If you can think about that as like a bounce or tangent, it just touches without actually crossing into the negatives or into the positives. Okay? Yep? Good. So if it's cubed, let's say this would have been a cube, is that even or odd? Odd, so we're back to crossing. So we're just talking about whether it's even or odd. For the most part, we're going to see a power of 1 or a power of 2. So you can kind of think of just like squared as bouncing or tangent, but you're right, anything past that odd or even, we could just look. Yep?
So if the parentheses is x plus 2 squared, it would bounce off -2? I mean, yeah, -2.
Okay, let's pretend this is it just for fun, okay? Take a look at this new example. I like Omar's question. This is our new polynomial. I just made one up. Our roots would be, as we find them, 0, -2, and 3. Agreed? Okay. However, let's go through our multiplicity. The multiplicity of 0, that came from this one, is odd or even? Odd. So it's going to cross at 0. Okay. At -2, it's
Even.
so it's going to like bounce or be tangent, and then at 3 it's back to odd, so it's going to cross. So this would, in general, at these points, we would know whether it's like bouncing or whether it's crossing through it. Okay?
So what if they're all bouncing? Is that gonna come up in a test? Like they're all cute.
They could technically like all do that as long as it's an even positive and it was like that. Bounce, bounce, bounce. Yep, you can do that. Okay, cool. So, great observations. What we're going to do then is turn to this example and 4 more on the back. this example and 4 more on the back, and we're going to see how we feel about graphing a problem like this. Hold on for 1 second when I kind of talk about one new thing. Okay. The nice thing about these examples is a lot of them are already going to be factored for you. See how this is already like factored into this form rather than like that kind of stuff? Okay, it looks different. So if it's already factored, that's great for finding our roots. However, it might be a little harder to figure out which of these it is because we don't have that leading coefficient in that degree like just sitting there staring at us, okay? So here's how we need to find the leading term in something like this, because we didn't get to these examples yesterday, so we're going to talk about it now, and we can go back to those examples if we see it. Okay, I could multiply all this stuff out with like boxes and distribution and all sorts of stuff and get my whole long polynomial. However, what's the only one that really matters for this?
The first one.
Like kind of like the first one or the one with the highest degree, right?
Yeah.
And so a way to just find that one and not really worry about the rest of the stuff is just to take all of these, but think about this one is squared, right? And multiply them together and we don't have to worry about the other stuff. So I've got x, I've got 2x, and I've got an x squared coming from each factor, right? From this factor I've got an x, from this factor I've got a 2x, from this factor I've got an x squared, right? So that ends up being 2x to the 4th plus or minus blah, 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 all this stuff. So you can identify your leading term. Make sure you're still with me. You can identify your leading term by just grabbing those kind of like first or those x's from your different factors, okay? So now that we see that, 2x to the 4th plus blah, 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 we don't care about the rest. We have our leading term and we can figure out our end behavior, right? Okay? We can also determine our zeros because it's already factored, right? And then we can also determine if the multiplicity, if we're bouncing or if we're crossing, and we can sketch it, okay? Let's jump in and see how we do. So help me out. Zeros, I've got x equals 0. For the next one, some of y'all might be able to do that in your head. If not, you're always welcome to like actually set it equal to 0 and solve. Yep. Then divide by 2, x equals -3/2. So if you can do that in your head and say, oh, it's -3/2, then that's cool. If not, set it equal to 0 and solve, okay? And then for this last one, what would make x minus 1 0? 1, and then 0 squared, right? So it would still be 0. You're just setting x minus 1 equal to 0. That'd be 1, okay? Let's talk multiplicity. For 0, if it's coming from this, are we going to cross or bounce? Cross. Negative 1.5 or -3/2, we're going to cross again. And at 1, we're going to bounce because we've got a multiplicity of 2, which is even. Okay? So let's draw our picture. Yay! I've got 0. I've got negative 1.5 is going to be between -1 and -2. -3/2 is -1.5. And I've got positive 1. Mine are all kind of scrunched up. If you'd rather make your intervals something else, you could do that. But I'm going to draw them right there. Okay, end behavior. We have our leading term. So let's go with Michelle. Help me out. This is a what? Odd, even, positive, negative. What is this? Even positive, so we're looking like this, right? This side and this side. Okay, let's cross and bounce. At first one we hit is -3/2. What are we going to do? Cross. I know this is going to be kind of small for something else. So we cross through that. Cool. And then I turn to come back up to 0. And what do we do at 0? Cross at 0. And then I'm going to turn and come back to 1. But at 1, I'm not going to go below the x-axis. I'm just going to bounce. I know it's kind of scrunched up, but I'm going to bounce at that 1 and head on up. If you graph it on your calculator, you'll see it just touches 1, but it doesn't actually go to the negatives at 1. Okay? Happy?
Yes.
Okay. Let's see how we do, and then you could always check by graphing on your calculator if you have, if you want to, like as you're practicing right now, okay? Alright, y'all's time to practice. There it is on the calculator. Yay, I'm glad I have it. That's prettier than mine. You see it? Cool? Cross, cross,
Don't be
bounce.
so hard on yourself.
And mine is struggle. Okay. On the back, 4 problems. I want you to just find the things, sketch the graphs, get better at this. If you have extra time, you can head back to page 15 and practice 3 others. So lots of practice. And then if we have time at the end, I can give you an exit ticket as well for more practice. Practice, practice, practice. Oh, sorry. Yes. Sorry. I messed you that up, Angela. Sorry. Okay. Who do I owe stamps to? Be honest. Be honest. Okay. And keep practicing. Like I just called on some people specifically, like I said like Omar, but then I didn't walk over there because we were still talking.
Okay, yeah.
So like sharing out, I mean if there's something else awesome that happens, I I'm coming. No, question? Yeah. Jigga ma jigger?
I am
Would be x times x times x is x cubed. So it's an inequality. Cool. Then you find your factors, and all of them would cross because there's nothing like square. Pedro!
No, but this way.
Okay. You take the x from each of the factors. So all these things are being multiplied, right? This is an x, this is a 2x, and this one is technically an x squared. If you multiply x times 2x times x squared, you'll get the first term of that big long polynomial, and that's x, x, and x squared. It's 4 x's with a 2. You're coming back to page 15, you understand these 4 that are on the back, right?
So how do you find
The leading, okay, so you take the x from all of the different factors. So these are all being multiplied, so we call them factors. So we take x, x, and here this is an x squared. So if I have x times x squared, there's no number that's going to be in front of it, so it's going to be a positive 1 as your leading coefficient, and it's going to be x to the 4th. 1, 2, 3, 4, you add them all, like our rules in school. Come in.
X equals 0. X equals 4. And that's it.
So this would be x times x times x squared. X squared would be x to the.
So you see this one, it has the squared. That means that it's going to be down. So for 1, when you put it in the graph,
Why is it down here? You gotta figure out your end figure
squared.
by finding your So multiply for me. X times x squared. Remember how we multiplied to everything? That would be x to the 4th. Yep, come on, Osie. Yep. Wonderful. Pretty. Okay, good. Next one. That was great. Wonderful. Yes, ma'am. Okay. So we want to find the zeros. So we want to find the place for the zero. You guys are when after we're doing a good zero. This would be x equals 0, right? Okay, that's another one. And then this one, even though Okay. Since these are we either on a graph like we're gonna go through those points on the x-axis, right?
I thought she had me like, then you can
I can either cross through that point and go from solid to negative, or I can barely touch it and scoot back up. So we're gonna do that.
1, 2, 1.
Okay, cool. We'll come back to that. So let's identify here which one of these is that gonna happen. Which one of these is it gonna happen? Okay, perfect.
Why the leaves?
And the other one is okay, cool. So the only thing you need to figure out now is your end figure. Up, down, down, side, side. And that is
How do you know when to
your
bounce
first like leading coefficient.
Right here, because this is
Slide out.
You don't know what the second one
We don't really know what our degree of okay. So the way we find out what it would look like at the beginning in like this form, you see the difference between these. This is the polynomial, this is back to the polynomial. We want to basically multiply this out to get something like this. So that we don't have to multiply everything. We just pick
I know, I'm more
from
perfect.
each factor. So over here we have x, here we have x, and here we would have technically have x.
Wow, you're so special. Oh, wow.
So that's going to be our leading term. There's not going to be a number because here we have one of them was a 2x.
What are you talking about?
Here we have none of these.
How old do you think my grandma is, dude?
So this is just
She's 73. Over what? It's good.
It's the same age as my grandma.
that's when you start drawing. Hey,
That's a joke. That's a joke.
okay. So what's the first one? So 0, 1, 2, 3, -4, and 1. Okay. And it's starting on this and like this, right? At -4, what do we do? Cross or bounce? -4. Okay. Which one of these? Let's go back. Sorry, let's check it right. Which one of these is squared? This one. So x equals 1 is going to bounce. Is that what you wrote?
2x to the power.
Do you see where we got that? The difference? Okay. So at -4, we're going to cross it. At 0, we're going to cross it. And then at 1, we're just going to touch it, bounce it, and bring it back up. Cool. Okay, try it on that one. See if you really got it, or call me after you have questions. I love it. Good. Perfect. Good. I'm coming. I know. I'm excited. So you don't need to multiply all this stuff out. You could, but it's going to get really complicated. So you get a box here, and then a box with this one. That's not what you put. So like we talked about, I would just try to find your first term. Try to find using x. So we got, you see those are the first ones? So the first term is going to be -x to the 1 plus 1 plus 2 is 4. Negative x to the 4th. Yep. You got -x, x, and x squared. -x, x, and x squared. That was -x to the 4th. So the ends are going to look like this, right? Down and down. I don't care about the rest of it. I don't care about the That's all we need for our picture. Okay? But yes, find it. Okay. We have that it's going to be down, down, right? Because it's inverted negative. Now we want to find where it crosses. I wanted, in this form, to find where it crosses, right? I want to know where it's equal to 0. It's going to be 0 at negative 2. It has negative 2 equals 2 0. Add
Yeah, you're
positive 3 and 0. 0, negative 2, positive 2. Okay? Which of these will be cross or bounce?
Order the one.
0. It's going to cross a 0 because it's not squared. It's going to cross a 3 because it's not squared. But what about the 2? You probably so you're going to go straight to this label. Keep practicing. Cross here.
But not like the second.
It's 17, right? That's what they made you say.
Wait, what?
Is that when they made it 10?
Guys, we're getting a little bit too rowdy. Come on, bring it back down.
Okay, then a few more seconds, then we'll pull it back. How y'all doing? These are crosses. All of these are crosses. All of what your picture is crosses, but this one should be a bounce. Yeah, but you didn't bounce. You crossed it and you also negative. So you need, but let's check your leading. This would have been. So here it bounces. Okay, let me come check in. I'm going to pass this out. Okay. You can pull out more than a square. Maybe 3. You can pull out x2. Good. Samantha, here, I'm going to give this to you. You're absolutely okay. How y'all doing? Are we bouncing? We're crossing? Okay. Okay, about 30 more seconds and then I close this out. Okay, so where's your starting and ending? Negative, so it's going to start down here, right? So start down here where we did first. -2. And bounce there. So just hit it, no problem. Oh, no, you can drop there. That would be another way. Next, you see 0. Come on, guys. Go to draw a dot. I would start with dot. Yep, go down. And then down. Alright, yellow, eyes up here. Eyes up here because I was answering Gio's question and I still want to let you out on time. I still want to let you out on time. I'm going to start possibly just like keeping us even past the bell until I got everyone's attention, starting to get antsy. Okay, for these, if you would like to look on your graph, I know not many people graph them, it gives you a better idea of like exactly how it looks. Because again, we don't really know how high this was going, right? Like you might have drawn it like, whoop, but it's hard to tell until you really graph it. But you can use that to check your answers, okay? If you're looking for more practice, go back to page 15 and you've got more there. Okay? And then you've also got your problem set. You should be able to go all the way through. The very last problem is what we're going to talk about tomorrow.
Yes, ma'am.
I'm here.